Ever wonder how doctors decide the best treatment for a patient? It's not just guesswork. It's a complex puzzle involving data, uncertainty, and the need to balance risks and rewards. But what if we could make this process smarter, faster, and more personalized? Today, we're diving into a groundbreaking approach called Deconfounded Warm Start Thompson Sampling, a method that's changing the game in precision medicine. Let's start with a simple idea: contextual decision-making. Imagine you're choosing between two treatments for a patient with a chronic condition. One is medication, the other physical therapy. How do you decide? In the real world, doctors rely on past patient data, but here's the catch: that data isn't perfect. It's often confounded, meaning hidden factors like the severity of a patient's illness can skew the results. For example, sicker patients might get more aggressive treatment, but that doesn't mean the treatment is better. It just reflects the patient's condition. This makes it hard to tell what's truly effective. This is where observational data comes in. It's like a treasure trove of real-world patient stories, but it's messy. Traditional methods struggle to separate the signal from the noise. Enter Thompson Sampling, a smart algorithm that helps make decisions by balancing exploration, trying new options, and exploitation, sticking with what works. But even Thompson Sampling needs a starting point. That's where Deconfounded Warm Start Thompson Sampling, DWTS, steps in. DWTS takes a two-step approach. First, it uses a technique called Doubly Debiased LASSO to sift through mountains of data and identify the most relevant factors, like filtering out the noise to find the signal that really predicts treatment outcomes. Think of it as a supercharged highlighter for data. Then it combines these key factors with hidden variables, those tricky, unmeasured influences like genetic predispositions or lifestyle factors that traditional methods often miss. Here's the magic. DWTS uses this cleaned-up data to warm start a Thompson sampling algorithm. Instead of starting from scratch, the algorithm leverages pre-processed insights to make smarter, faster decisions. This is especially critical in healthcare, where delays can have real-world consequences. But how does this translate to real-world applications? Let's take a step back and look at the data that fuels these innovations. Consider a dataset tracking human health metrics, like cholesterol levels or kidney function. This isn't just a collection of numbers. It's a window into the vast variability that defines us. Some people naturally have low cholesterol, others struggle with it. The dataset captures this diversity, showing not just averages but the wild variations that make each of us unique. Yet real-world data isn't perfect. It's messy, with gaps, inconsistencies, and surprises. Imagine trying to piece together a puzzle where half the pieces are missing, and the rest don't quite fit. That's what researchers face every day. They've got to use clever tools and smart strategies to make sense of it all. Why does this matter? Because understanding these patterns isn't just academic. It helps doctors tailor treatments and policymakers create better health strategies for everyone. It's about turning chaos into clarity so we can all benefit. So the next time you hear about breakthroughs in precision medicine, remember, they're built on the foundation of rigorous data analysis. Techniques like DWTS are pushing the boundaries of what's possible, ensuring that decisions are not just informed, but optimized for every individual. Stay curious, because the future of healthcare is being written in data. Until next time, keep exploring,